Assalamu alaikum. Thank you for watching in this video. In this video I will teach about physics and chapter 2, measurement. First of all, learning objects. In this video I will teach physical quantities and derived quantities. And physical quantities and derived quantities, let's begin to definition and their description. First of all, physical quantities. I will teach you introduction. What is physical quantities? All measurable quantities are called physical quantities. Scientists have divided all physical quantities into two groups. Number 1, fundamental quantities, and number 2, derived quantities. Okay, first of all I will tell you description more about physical quantities. Allah Almighty has created everything in the world with the best estimations, from huge celestial bodies to subatomic particles of atom. Everyone is working in the domain under certain principle which has been assigned for by it Allah. Man has discovered three principles. A physicist is largely involved is discovering the law of nature through the precise measurement of very physical quantities. Scientist has divided all physical quantities into two groups: physical fundamental quantities and derived quantities. In physics, length, mass and time are supposed to be main fundamental quantities. You should keep in mind, length, mass and time are supposed to be main fundamental quantities. Since scientists all over the world has fundamentally recognized that all physical quantities in the mechanics can be expressed in the term of these quantities. To measure physical quantities we need to certain units. Now let's move to physical quantities definition. Now I will teach you take example why we need to physical quantities. Now if this is a picture show, you can see here a cable, and from point this to this point, and we feel first of all we will need to some basic things. Physicists like other scientists to make observe and ask basic questions. For example, how big is an object, how much mass does it have, and how far did it travel. To answer these questions they make measurements with various instruments such as meter, stick, balance and stopwatch. Now these quantities, meter, stick and balance, stopwatch, these are the measuring instruments which is used and required for the measuring quantities of the object. Now it's a unit used through the world. We define the basic system of length of the meter. If we measure the length of a meter, this is now the length traveled by a distance 1 meter, and when light travel a straight line from point 1 to this point and travel between these covered distance in the taking time t. Now this time distance travel we will measure through the some instrument scale, and time from the light from that point to end point with the measure of stopwatch. Now you can see again a picture here. Historical International Photography meter bar, which is alloy of a platinum and iridium, which was standard from 1889, which is in the France, and which standard meter which is used in all over the world for measuring instruments and measuring quantities of the objects. The current definition of meter, which is defined as definition of meter: the meter is the length of path traveled by a light in vacuum during time interval of 1 divided by 29979924458 of the second. This is second, and 1 divided by time light travel from at this point to this point taking time into second, and 1 divided by this is the called time interval. It is the defined as the distance to marks engraved on the iridium platinum alloy bar kept at the International Bureau of Weight Measuring near the Paris. This is the International Bureau measuring near Paris. This is the definition of standard meter. It is clear. Now again we will now about standard of time. In October 1967, this is, you can see a picture. This is the microwaves, and this is the cesium atoms, and this is the counter clock device which is used to detect the waves, and this is the frequency originate from this source. In October 1967, the time standard again redefined the term of atomic clock. Atomic clock used the cesium of atom. This is the atom of cesium, and which atomic, and the cesium atomic number is 133. You can see in periodic table cesium atomic number 133, and the cesium atoms vibrate and complete rotation around its nucleus, which takes some time t, and the waves are traveling from source. According to this clock, a second is defined as the exactly equal to the time interval of 9192637 vibration of atom of cesium. The time interval is equal to the cesium atoms which is used in counter clock, which is used in this device to detect the waves. It may be possible that the two cesium clock running over the period 3000 years will differ by the 1 second only. This is the standard time. To travel, a second is defined exactly equal to the time interval of the vibration atom of cesium. This is called second standard of time. Now, standard of time is the device, which is actually picture of, you can see here, and again the matter of the hydrogen atoms. Another clock has been invented with has hydrogen and known as hydrogen measure clock. This clock was achieved the precision of 1 second in 300,000 years. It measures that if two hydrogen measures clock were started simultaneously and they are allowed to run over the period of different 30000 and 000 years, then expected the difference between their times would be only 1 second. The advantage of the method is the cesium clock or hydrogen meter clock can be strictly controversial laboratory, and the standard time second can be checked. Now we will conclusion draw the hydrogen atom and cesium atoms. This it is the note that matter how to standard is defined, method always involved some sort of periodic motions. Now this is depend upon the periodic motions of the atom. Atom's vibration motion depend upon the atom. Now next, standard of mass. The physical quantities, standard of mass, time and length. Now standard of mass, 1 kilogram is the mass of platinum iridium, which is you can see here the standard world accepted object alloy under the kept of International Bureau of Weight and Measure in service near the Paris. Replica of the international agreed standard of mass have been sent to several countries. Multiplies and submultiplies of meter, second and kilograms are given below. You can open your book, page number 15. Page number 15, you can see there page number 15, page number 15. Okay, page number 15 open, and you can see 1 kilogram is equal to 100 meter. We can in scientific notation 3 raised 10, and 1 centimeter is equal to, when we convert centimeter into meter, we will divide 100, and which is equal to -2. We will you can all definitions and all conversions of quantities you can see at page number 15. Okay, now again what is the fundamental quantity units? Fundamental units. Okay, fundamental units. Units that can only express relative to procedures used to measure them. In the system, 7 basic quantities have been assigned as fundamental quantities. First of all, you should keep in mind 7 basic quantities: mass, length, time, current, temperature, amount of substance, luminous intensity. These are the fundamental quantities, and these are the fundamental units. Symbols we can mass m, length we can use L, T we will use time, current we will I, temperature T, amount of substance N, and luminous intensity LVI. These are the basic quantities, and this is the basic symbols and used in SI units. This is the fundamental units. We can use mass into kilogram. Basic units, mass of unit kilogram, you will keep in mind, and after we will do numerical solve and other problems, these quantities are useful. Okay, kilogram, kg, meter, small m, second we will use symbol S, ampere is the unit of current, capital A, Kelvin which is the temperature unit, K, and amount of substance, mole we can use m mole. Candela is the unit of CD, which is luminous intensity. This is the 7 basic units. We will these are the fundamental units, and the fundamental units we will use to derive up derive quantities, which is called derive units. Quantities. All physical quantities derived from the fundamental quantities are known as derived quantities, and their respective unit is called derived units. Derived units are obtained the multiplication of fundamental units. For example, volume of a box is equal to the length, breadth, and height, that are meter multiplied by meter multiplied by meter. You know that length, breadth, and height, these are also actually lengths. We can measure in meter, and we can again write here meter multiply by meter, which is 3 times of m, and the power we will add, and m cube. This is the fundamental units we use to express, and we will find the derived quantities. Meter is the fundamental quantity, so meter cube is derived quantity. You should keep in mind meter 1 is fundamental quantity. We will add 3 times of meter, which is equal to derived quantities. Similarly, speed, acceleration, force, density, area are the derived quantities, and their units are derived units, and we will find this unit of speed in next chapter. Acceleration, force, unit of force, density, area, these are the derived quantities, and we will use to fundamental units, and with the solve derived units with the help of fundamental units. Derived units, units that can be calculated using algebraic combination of fundamental units. We will use the combination of fundamental units. We will use derived units. Now these are the derived quantities, some quantities here. Some derived quantities are their derived units with the symbol are given in. For example, volume, unit of m cube, meter cube. Meter cube is the derived quantity, but single m is the meter of basic quantity. Density, which is equal to mass per unit volume, which is the formula, but kg is the basic unit, meter cube is the basic unit. Both are combination is the derived unit. Velocity, which is a combination of basic units, meter and second. Force, which is equal to Newton, and which is the basic unit force. Basic Newton, and which is equal to which is the combination of basic units. Acceleration, meter and second per cube square. This is also meter. This is a combination of basic quantities, and which is equal to meter per second square. This is the derived quantities, and this is the fundamental quantities. Okay, fundamental quantities and derived quantities. It's clear. Now question answers. What are the fundamental and derived units? These I have already described. Question number 2.1, you can open page number 29. Question answers. Write the answers of the two questions. Answer what is the fundamental and derived units. You can write the answer of this question. I have already described and precise these question. I will teach you again. Okay, practice these prefixes. This is the factors. Prefixes also used to word. Prefixes means we can in system international units we can express in simplification and in exponential form, and we will use 10 raised power 8. You can start from this factors 10 raised minus 1. This we use symbol D. Centi VL 10 raised minus 2, which is equal to 1 divided by 100, and 10 raised minus 3, which is equal to milli, and 10 raised minus 6, which is in micro, and symbol U. These prefixes are used to in further we will solve numericals, and again you will practice these prefixes, which is helpful for the solving problems. Okay, thank you for watching this video, and more questions about your mind. Thank you all of you.